Hello and welcome to Aging Matters, a program featuring people who talk about issues of interest to older adults and their families. I'm Cheryl Beversdorf, your host. Today, Aging Matters TV show is pleased to present the second episode of a three-part series called Aging Research. This episode focuses on machine learning and gamification research to improve cognitive skills and physical movement in older adults. My guests are Dr. Eric Bubar, founding professor of engineering, and Jenna Kniceley, pre-physical therapy student at Marymount University. They will talk about developing and using emerging technologies like machine learning and maker tools to support aging-related research projects. Later in the program, you will see video demonstrations of how a computer webcam can use machine learning to gather movement data while a person exercises and make suggestions and recommendations to assure an individual is safe and effective in performing their exercise program. So welcome Eric and Jenna, and thank you for joining me today.
Thank you for having us.
Thank you.
All right. Well, Eric, we need to get an overview here. Help us understand more about Marymount University's engineering program that uses maker technologies to create biomechanical engineering research projects. That's a mouthful.
Absolutely, it is. I get it wrong half the time when I'm talking about it too.
Okay.
So we have a new engineering program at Marymount, and we offer 2 degrees. We have a Bachelor of Science in Mechanical Engineering and a Bachelor of Science in Biomedical Engineering. And what I do is I combine the mechanical and the bio to do biomedical, or biomechanical. See, I got it wrong too. Biomechanical engineering. And what we do in our program is we have a philosophy that anyone can engineer. So we want to make an engineering program that's inclusive to anybody. And so that any student can come in and study engineering at our school, even if they don't have prior background, if they haven't built robots or had those opportunities in their high schools, they can come to Marymount and do projects and succeed in engineering. And what we want to do to make this possible for them to succeed is use maker technologies and maker tools.
How did this concept lead to developing and using maker technologies to support aging-related research projects? Give us a little more information about that in terms of reaching out to some of your colleagues over at Marymount.
Right, so how did we get there? It's kind of a strange tale, because my background is actually in applied physics and astrophysics. And we had a student, in I think it was 2013, who was interested in learning about this new technology called 3D printing. And now 3D printing is one of those maker technologies, maker tools. And with a 3D printer, you can kind of create whatever you want. You can make a 3D model and build up whatever structure you can think of. So what she did is she saw this story about a child that was missing a hand. And some makers created a 3D printed Star Wars hand for the little girl. And this student just thought that was awesome. And I'm a huge Star Wars fan, so I thought it was awesome. And we talked to the university and said, this is very cool. We think we can do this here. We want to start studying this new kind of emerging technology of 3D printing. So we got a 3D printer. At the time, they were very complicated and very difficult to use. But we got that, and we started creating 3D printed hands for people. And that's really how we got started in kind of biomedical engineering, is making hands and arms for kids all over the world that needed them with 3D printers. And then I started talking about this and had some media coverage, and then my colleagues found out that I could do these things. And that's when the flood doors opened up. And I just had people coming to me asking, oh, could you do this? Our physical therapy program came up to me, and they were working on a project called Go Baby Go to convert Power Wheels cars into wheelchairs for kids with limited mobility. And one of the most expensive parts of that was this big red button. They'd converted the cars to work, instead of using a pedal, to have just a big button that you push. That button cost $50. The car itself was about $200. So it was a huge cost, and they said, can you make this for us? So sure, we figured out how to make it, and we could make it for about $5. So we do those kinds of projects, and other faculty find out what we can do and just come to us with their ideas.
And to your knowledge, are they doing this in other places, or is this pretty much unique to Marymount?
This is a wide-scale effort. Making is happening all over the world.
Okay.
Actually, just before I came in here tonight, I checked to see how many events revolving around making were occurring around the globe. And there's an officially sanctioned maker event called Maker Fair. And they have these in cities all over the place. They've had them in Virginia, in Fairfax, in DC. And between now and November, there's I think 60 different maker fairs going on. So all over the place. And these kinds of projects happen in various different forms. So one of the big groups that I work with that does this is called Enable. That's about 10,000 people all over the world making 3D printed hands and arms for kids. The PT department runs their Go Baby Go cars to convert the power wheels into wheelchairs. That's happening all around the country, all around the world. Lots of people doing that.
Okay, so that's very helpful, and that kind of leads me to Jenna, who is in physical therapy, correct? And
Yes.
so how did you get started in this kind of work?
I actually got involved through Dr. Bubar. He came to my physics class in the fall semester, and he essentially said, I know the engineering part, and my physics class is all physical therapy students. I need help with the actual physical therapy part. And I reached out to him and I was like, I would love to get involved in your work. And we worked together on 3D printing a hand, and we went to the East Coast Rep Rap Festival in Baltimore to represent the Enable Marymount chapter. And then I just started working with him as far as AI research and VR research and just kind of getting more involved over time.
And so now, how do you and your fellow students, I'm assuming there are other students as well,
Yes.
doing this, how do you decide what projects to develop? Again, you are talking about physical therapy and we're talking about aging. How did you come up with, or how do you come up with ideas that are specifically related to aging, say?
Yeah, I know I take a lot of inspiration from the things around me. So with my physical therapy classes at Marymount, and I worked in VCU Health System as an observer, as well as Pivot PT as an observer. And I currently work at MedStar as a clinical assistant, so kind of taking the PT knowledge I know from there. And Dr. Bubar does a wonderful job of letting students do what they want and getting ideas that they're very passionate about, but also giving his perspective as an engineer. Is this realistic? Is there something that we can do within Marymount? How can we go about doing this? Because I know with my projects personally, you have said, okay, now let's do this. Or this is the first steps that you would take for this, and this is how you proceed, which has been so helpful, especially because with the promise of anyone can engineer, I had no engineering experience.
So you start working on this project. Does it all go smoothly right away, or are there challenges, or how do you learn? Do you learn as you go along, or how does that work?
I definitely think it's learn as you go along. I know for me personally, when I first started the AI, Dr. Bubar had taught me the foundations of it. So this is the code, this is what it means, this is what you do. And then I personally looked up codes and then I broke them down line by line to see, okay, what does this piece of code mean and how does it affect the code? So kind of creating that foundation, which was very challenging at first, kind of figuring out what things are and kind of converting coding language to something that I, as a physical therapy student, can understand. And I think another challenge would be gathering data. Just because with things like AI and teaching it to recognize certain things, it can only recognize what you teach it. So if I taught the AI, like myself performing exercises, it can recognize me, but it won't be able to recognize Dr. Bubar because we are built very differently. So actually Dr. Bubar is developing right now synthetic data, which we can create characters of any shape, size, and color and teach it to the artificial intelligence so it can be able to recognize all of those shapes, size, and colors in patients.
Okay. Well, and so Eric, getting back to you, have there been any surprises or unexpected outcomes and in this whole process, working together with Jenna or just generally that you've experienced?
Yeah, I think if we didn't have surprises, we're not doing very good engineering for the kind of emerging kind of technologies we're looking at. So what surprises me a lot is how quickly a lot of the students are able to pick this stuff up. Like Jenna said, she didn't have any background and picked it up right away and started learning how to do coding, learning how to do programming, and had functional prototypes within a couple weeks. Very, very quick studies. And also it's surprising to me how easy it is to work with people. I'm a physicist and an engineer. I'm used to sitting in the basement and just playing with my computers. And Jenna has taught me how to work with people and actually understand what people need. So,
you are about to see several demonstrations of what we've been talking about, of how webcam video games can be combined with machine learning to provide real-time feedback on keeping safe and proper form for individuals performing an at-home exercise program. So let's watch.
So research tells us that one of the best things that you can do to counteract any negative impacts from aging is basically just to exercise. So if you can teach your brain how to react to new experiences and external stimuli through this exercise, something called neuroplasticity, we can create new neural pathways and strengthen your cognition and improve overall health. So in my lab, we're exploring this using both augmented and virtual reality games that are controlled by something called machine learning. Now in this first example, we're using something called augmented reality, which is basically drawing virtual objects on real-world objects. And as you can see in the video, the computer has kind of drawn a stick figure that represents my body. And this stick figure is actually created by this machine learning. It's been taught to recognize points on my head, my shoulders, my elbows, my hands, my hips, my knees, and my feet. And it's drawing this skeleton figure, and it's drawing this in real time. Super, super useful. And what I can do is I can take all this information. I can take all the points that it's tracking, and it's doing all of this in real time, and I can analyze this and see how well I'm exercising and if I'm exercising safely. And I can do this while exercising or after I'm done exercising. And we can furthermore program this system to monitor me while I'm exercising and make sure that I'm exercising within safe limits, that I'm not moving too fast and I'm not moving too far out of safe ranges. Say if I go through surgery and I'm in a rehabilitation program. Now to make the exercise fun, we've put it into a classic video game called Tetris. And that's what you're seeing on this screen. You see a transparent grid of squares, and the purpose is to move these shapes that are falling down very, very slowly and form complete colorful rows at the bottom. And once I form a row, that row will disappear and I'll score points. I need to move these shapes left and right, and I need to rotate them and line them up so that they will actually form these complete rows. And I can do this by doing different exercises, and we can program whatever exercise we want. So if I want to move this shape over to the kind of right-hand side, I can balance on one foot, and that'll move the shape whichever direction I want it to go. So I can move it left, or I can move it to the right by balancing. And I'm only going to move those shapes if I'm balancing correctly, if I'm doing the right move, and if I'm doing the exercise perfectly. So rather than just send you boring kind of feedback saying, yes, you're doing this right or wrong, what we're doing is we're gamifying this. We're actually seeing that we are actually getting the motion that I want by doing an exercise correctly. So if I want to rotate that shape, I have to hold my shoulder at the proper angle to get this to rotate. And then once I get the piece rotated, I can move it by balancing on my foot. And then I can move this shape down by doing a squat. So this is monitoring me in real time, giving me real-time feedback, and if I'm doing exercises correctly or not. So the square, maybe I want to move this over to the corner, to the side, so I can balance on one foot. And then I can do a squat to make the shape go completely down. And this computer is monitoring me at all times. So what I'm doing here is I'm having to make cognitive decisions and decide, how do I need to move this shape? Where do I need to move it? How do I need to rotate it so that I can get it into the position that I want it to get into? Let's see if we can finish up a row. So I've got the shape rotated, and I want to move it and get it to fit right there into that second row, that little piece. And then as I move down, we'll see that row will disappear, and I will score points. So what we're doing here is we are combining both cognition and we're combining exercise with that, which helps us to develop, again, that neuroplasticity. So in the second example, we are using something called virtual reality. And this is where we put a user into a completely virtual world. So when I move this headset down, what you're going to see on the screen is what I'm seeing in this headset. And that's all that I'm seeing. I'm not seeing my couch. I'm not seeing my dog napping in front of me. I am only seeing what's inside of this virtual world. So we can control everything that you see and hear inside of virtual reality. And our goal here is, again, to develop neuroplasticity. So we want to combine thought and thinking with exercise. And what you see here is a pink kind of sword in one hand, and I have a green sword in the other hand in this game that's called Beat Saber. As I continue, we're going to have some blocks that are moving towards me. I'm going to have pink and green blocks, and I need to cut them with the right color, and those blocks have an arrow on them, so I need to cut them in the direction of the arrow. So there's a lot of cognitive processing going on here that's linking up to physical movement. And while I'm doing this, I'm developing new neural pathways that are encouraging that development of neuroplasticity. And one of the challenges of virtual reality is I am entirely in this virtual world. I kind of lose perspective on what's going on in the real world. So there's a danger that I might get disoriented, or I might fall or otherwise injure myself because I don't perceive the entire world around me. You can get so into these virtual worlds that you don't realize that you're doing things unsafely. So to make this safer and more effective for at-home exercise, we again have that same system that was monitoring Tetris, and in this case, it's monitoring me playing this game. And it's popping up some numbers. Those numbers are tracking my positions, so where my center of gravity, the center of my body, is moving. If that center of gravity is moving in a safe way, so that it's not kind of moving outside of where it's safe for me to be, if it's moving outside of where my feet are, that's called base of support. So as long as that number, that word true shows up, I am not kind of deviating outside of where I will be balanced. And then the last number is an extrapolated center of mass. So this is calculating where will my center of mass be based on how I'm moving. So if I start moving really, really fast and moving kind of outside of safe realms and kind of moving in ways that are maybe unsafe, this system will watch me and monitor me and predict where I might move in the future and stop me from moving in such a way that would be unsafe and lead to a fall. So in this way, we can make augmented reality games that are fun for neuroplasticity development, and we can create immersive virtual reality games, and you can be confident that you're going to be safe in doing so.
I hope the demonstrations were helpful in understanding how computers can watch an older adult exercise and, based on the person's performance, make suggestions and recommendations as to how greater benefit from exercise can be achieved. So Eric, having watched this demo, this technology seems very complicated, maybe to older adults. So can anyone use this technology? Are there different types? Tell us more about that.
Absolutely. So because our engineering program is really founded in maker technologies, one of the big things that makers like to do is follow something called open source development. And what that means is whatever we create, we try to make it accessible and open for anybody to freely use and to edit to make it easier for them to understand and use themselves. So this is great. It's a great way to innovate and build on top of other people's work, because maybe I create this Tetris game, and then somebody's using it, maybe an older person is using it that has some programming skills, and they think, oh, if I put this in, it would make it easier for me to use. They can then do that. Or they can contact me and I can do it. So this open development, very good for innovation, and we try to follow those rules.
And I also understand that I think there's another term that we were hearing about, immersive virtual reality. What is that? What does that mean?
Yeah,
Tell us more.
That's very confusing for a lot of people. It's confusing for me. When I read the literature, they talk about virtual reality. And in my mind, virtual reality is what we call immersive virtual reality. And that's when you saw that I had this headset on.
Yes.
And I'm entirely immersed in that virtual world. I don't see anything going on around me. If I had a virtual headset on right now, I couldn't see any of you. And you could be poking me and poking at me, doing all sorts of crazy things, and I'd have no idea. In immersive virtual reality, you are entirely within a virtual world. And that's great for this kind of research because we can control everything that you see and everything that you hear. So we can put you into virtual environments and really control everything that's happening to you. And we can do it in a very safe, effective way because we can control the environment.
So let's get back to aging research. That's what we're really focusing on. These technologies that you're describing here, why are these technologies useful for aging research? And what is going to be, or what is the overall goal for implementing these tools? It sounds so complicated, and yet we have a specific goal in terms of aging. So
right. I think a lot of the big benefit here is that open source model. So what we can do is we can try things, we can put people into new technologies, and we can see what they think about it, and we can rapidly change it and adapt it to make it work for whoever wants it. Another nice feature of this is I like to say we can do bespoke solutions. So I can create these technologies to individually serve an individual person. And as you're aging, every person ages differently. Every person needs a different exercise program, has different ranges of motion that they can do, has different exercises that they need to do, has different abilities, different balancing that they can withstand. And what we can do with these technologies is with this virtual reality, with this maker movement, we can create something that will work individually for you and maybe not for anybody else, but it's customized to an individual person.
So if I understand it correctly, this being open source is important for this kind of work because it's more based on the individuals. Is that correct?
It really is, yes.
Okay, all right. So Jenna, again, we're getting back to physical therapy here and that. What do you hope to accomplish? What's your goal here? Now you're involved with this. What do you want to do? What do you want to accomplish?
Well, I guess the general goal between Dr. Bubar's and our work is very broad in terms of AI is very new to healthcare, and incorporating it into clinics. I guess the kind of goal would be to see how far we can push AI to help patients. So like kind of the work that we're doing right now, seeing if we can create AI that can recognize exercises so patients can bring them home and it can correct their form and teach them how to do the exercises.
And will it just be the individuals themselves, or would their families be involved, or not? I was just curious as to how far you can go in terms of what this could look like.
Yeah, of course. In terms of physical therapy, usually patients are given at-home exercises by their physical therapist. So these are exercises that they perform at home alone. And usually what happens is the physical therapist teaches them within their session, and then they go home and then they do it themselves. So the AI would help them correct their form because the physical therapist can't be there. And a lot of times what happens is a lot of patients don't do their exercises, not at their fault. It's just they either don't know how to do the exercises, or it's difficult for them to do on their own, or they don't have the correct form. So this would be another tool in their toolbox that they can use while they're at home. Their family can be involved if necessary, but the AI would generally focus on them individually.
And are there current projects that are ongoing right now? I mean, are you working on a project? Are your colleagues working on projects? Tell us more about what you're doing or
Yeah.
what your colleagues are doing.
Yeah, of course. The AI research is ongoing. I personally am trying to create an AI balance error scoring system, which they use a lot in physical therapy. It essentially assesses a patient to see if they are at risk of falls. So they stand on two legs, on one leg, and then in what's called tandem stance or heel to toe stance. They do that with their eyes open and then with their eyes closed. And anytime they waver or they fall out of that stance, that's known as an error. If you have a certain number of errors, then you are considered a falls risk. So what I'm creating right now is an AI that can recognize these errors, and so patients can track their progress.
What's going to happen with your findings? I mean, both for you and what you're doing as well as your colleagues. I mean, what are the next steps?
I think overall just developing the engineering program and showing students this is what you can do. Especially, you can come in and be able to learn these things from Dr. Bubar and his other colleagues, and you can learn to be an engineer on your own. So yeah.
I'm also wondering, one other thing, I am aware over at Marymount University, they have a nursing school there, and so I'm wondering if this could also be brought into other healthcare providers besides physical therapy students, that this could also be something that.
So we're talking to the nursing school, and something that's become big in nursing is virtual reality training. So you don't need the patients there, you can train them on virtual patients. And we're going to start exploring how to do that. And I think your earlier question about how can you get family involved, that's where I think this is going. We're going to create games and gamify this. So you saw some examples of those games that we're making. And that's really to make the exercise fun so that people stick with it and they do it and they enjoy doing it. And then what you can do is you can get the family involved.
And so if people, are you looking at this point for participants at all in the study? Or I'm just thinking if individuals want to contact you with questions about the research that you are doing, or they have some ideas perhaps, what would you tell them to do?
Right.
Get in touch with you, or what?
Absolutely get in touch with me. They can contact me through my email. They can reach me through the Center for Optimal Aging, the Marymount Center for Optimal Aging. I'm a faculty affiliate with them. And if they have ideas for what they'd like to do, let me know, and we can create whatever technology they want. If they want to try virtual reality games, let me know. We can bring them in and they can try them out.
Well, I want to thank Dr. Eric Bubar, founding professor of engineering, and Jenna Kniceley, pre-physical therapy major at Marymount University, for joining me today. This program is broadcast Sundays at 5:30 p.m. and Wednesdays at 6 p.m. on Comcast Channel 69 and Verizon Channel 38 in Arlington, Virginia. Aging Matters is also on the radio. The program is broadcast every Tuesday and Friday at 2 p.m. on WERA Arlington 96.7 FM. Be sure to check out the Aging Matters website, agingmattersonline.com, for more information about our radio programs and our TV episodes. So thank you for watching the program today, and please join me again for the next Aging Matters show. And until then, remember, age is just a number, not a label.